So this is Bogo, the firefighting robot. The idea behind him was to make a situation safer for firefighters. So instead of sending a firefighter into a burning building and not being able to see through the smoke, not knowing what the situation is, you could send Bogo in and he would send camera feedback in to the user so you can survey the area and then put out smaller fires with the pump tank on top before they turn into bigger fires. And then later firefighters can go in and finish their job. So some of the features we have with Bogo, he has 2 motors to control movement and then 4 proximity sensors for object avoidance. He has a water pump and water tank so that he can actually extinguish some fires. He has an LED and buzzer for a warning signal once the pump is actually going off. We have a GUI for user controls so then the user can see a camera stream and see which buttons they're pressing for movement or the water pump. We have Bluetooth enabled for the actual remote use for it, and then a test environment that we made for safe demonstration within the lab.
So a basic block diagram of our system. So the PSOC6 is the main microcontroller we're using. It's wired up to the motors, the LEDs, which come on with the pump. The buzzer also comes on with the pump. The proximity sensors are also wired up. And then that talks via Bluetooth to the GUI, where you're allowed to control all of these systems. And then basically separate from PSOC is the RPI, which we use for the camera streaming. So some of the difficulty we encountered was our custom board. Basically our Bluetooth connection was dropping too easily. So some of the things we didn't really follow was there's a little keep out zone for the PSOC that we had a few vias and polygons underneath, so that was causing a lot of interference and then our connection would just drop all the time. So some of those fixes, I guess the first one was this spider MCU where we tried to just raise the MCU into the air and mod wire everything. This didn't really work as well. So we went to the second fix,
which was we used the dev board that we were given at the beginning of the semester and just used the MCU on there and then mod wired everything so we could use the custom board components that we had. So we weren't sacrificing too much, but we were still able to get most of our custom board functionality. The only thing we had to modify was the use of the MCU.
Another big issue we had was that with all of the components we had on Bogo, like the pump and the servo motors, a lot of times when you're using them all, it'll draw way too much current and our board wasn't built to handle that. So we get like our voltage all dropping and then the board itself resets because the voltages are too low. So our fix for that was basically to try and add capacitance to smooth out those drops, make it not as severe, and hopefully keep it high enough that it doesn't reset the board. Now obviously if we had more time, we could fix the issue entirely and build the board to handle more current so we wouldn't even have to do this. But this was just a little bit of a band-aid for the current situation. So yeah, the pump, I mean, as of the morning of the demo, the pump was kind of a one and done thing because it would draw too much current, reset the board, and then all of the pins on the I/O expander would kind of be set to read, so you wouldn't be able to like communicate with the pump anymore.
And then the only other issue we had that was a major one was we weren't able to get serial through our custom board, like to talk and get any errors that were from the MCU, but that ended up not being too big of an issue because we couldn't use the Bluetooth with our MCU on the custom board anyway, so once we switched back to the dev board, we were able to just use the serial through there. And then some of the design decisions we had that were separate from like the actual electronic setup for Bogo was we went with a pre-made tank that we got on Amazon. It was very heavy duty. It was rated for 5 kilograms of weight, which is about 11 pounds. So it was able to handle the weight of the tank being full, and the pump is heavy, and we've got 2 battery packs in here to power our boards. So we wanted to make sure we were getting something that wasn't going to cause issues once we actually got all of our components working. We didn't have to worry about the mechanics of anything. We're not mechanical engineers, nor are we trying to be. And we were also trying to keep our electrical components clear of water, so initially if we had just our one custom board, this box would have had like a lid to it, and all the holes would have been taped up with electrical tape and fit underneath the body of the tank. So then it would be separate out of the way, wouldn't get any water on it. But with the way that we had to do it with 2 boards, then we just kind of had it on the back so it was out of the spray of the water. And yeah, the one custom board was easier for us. We kind of had our Franken boards, as we called them, taped all over when we were like demonstrating this before we made our custom board. And with boards being everywhere and Ethernet wires going crazy, we decided that one custom board was the way to go.
All right, so we're going to give you a demonstration of Bogo working now. So from this PC, we will have both a camera stream as well as a graphical user interface running. I created a script that puts those both together in unison. So I'm going to have Alex assert a reset for me now, and I will run this script, and you'll see some windows pop up. So here's our GUI right here. Set that over here, and you'll see a camera boot up in a moment here. There we go. Okay, so as you can see over here, we have a temperature reading. Everything looks good. We're at an average temperature, but as you can see here, there's a warning. We are asserting a proximity sensor is telling us that we have an obstacle in the back. So I won't be able to move back, as you can see. So I'm sending motor commands to go backwards. Nothing can happen. I'll go forward. Oops. Forward. And now, as you can see here, we have no proximity warnings because there are really no obstacles in front of us. I'll have Alex put his hand in front. So it tells us that there's an obstacle in front of us. And I'm going to do a forward command. Nothing happens. And then I will have Alex remove his hand and I'll go forward. I'll show you us running into the wall. Cade has implemented a failsafe for when we do run into a wall, the motors will stop working and I can't go forward. However, I can move away from the obstacle. Yeah, so I think we're ready to start putting out some fires for you guys. Yeah. Let's put a little sandwich. My sandwich. Alright, so as you can see, I forgot to put out one of the fires. I'm going to go back over and get that taken care of. But take note, in the back you'll see these LEDs that are turning on, and if maybe you'll be able to hear it, but there's a buzzer that also goes on. And then also, we have servos that are supposed to raise and lower the hose. Let's see if we can get that demonstrated for you. So we had some issues with, you know, the hose that we were using is a little too rigid. So what we think happened is the servo is, there's some strain happening on the servo, and that kind of puts us into a reset stage where we weren't intending for that to happen. But nonetheless, we can see slight movement. So you can see the idea.
So this is our functioning CLI to test Bogo, make sure everything is working. So this is our temp function, which returns the current temperature on the temp sensor. We can flash the lights. You can see the lights turn on and then turn them back off. We can set the servo to a certain degrees. So you can hear it happen there, maybe I'll do a larger one. So he spins and then he can go back. This is him going back to 0. We also have a buzzer function, which I might have typed wrong. There's the buzzer, and then you turn it off. There's prox readings, so if there's nothing in front of anything, you get no terminal output. But if Doug puts his hand in front and we do a prox reading, we get a warning for forward, and then we can get a warning for right, and then we can get a warning for the left side, and then finally behind. Oh, that one didn't. There it is. So those are all the prox warnings. And then finally is drive. So hopefully I can do this quickly, because if I don't, he'll hit the wall, but we'll go drive forward, and then stop, and then come back, and stop. We're gonna turn. Can you move them a little bit to the center there, Alex? So I don't hit the wall. Okay, perfect. And then we could turn and stop, and then we go back the other way. And finally is the pump. Are we in a good spot? Maybe a little bit to the. If I can do this quick. Oh. Sorry, everybody. This is fine. And then we can turn the pump on, and we can turn the pump off. There it is. That is our functioning CLI. Sorry, I'm a bit rusty with the commands.
So, what I was responsible for is I basically did the schematics and PCB layout and routing for the combined board back here. So that includes obviously everything, but the main thing I worked on that board was the power design. So we used a 12-volt battery pack to supply power to the board, and then we had a buck regulator to buck that down to 5 volts, and then from there we used a linear regulator to step that down once again to 3.3 volts. So, along with all the power and the PCB, I was basically responsible for setting up the proximity sensors on all sides and doing a little bit of the software for that as well.
Okay, so my contribution hardware-wise was placing components on our PCB, going through a couple revisions of that. Additionally, the RPI camera, we wired that through the chassis. It's within the chassis here, but most of where my contribution was with software. So, defining Bluetooth characteristics and services with Cade, getting both the camera as well as the GUI to work in unison. So I created a script to compile both of those and run those together, and just debugging the countless Bluetooth issues that we had along the way.
So my hardware contributions were with the LED board here and the buzzer, which was kind of not audible during actual running, and then doing everything with the pump and the relay circuit with that. And then I did some testing or training at Makerspace for laser cutting to do the acrylic box, and I built the 8-foot test environment that we were running this all in. And then I helped with the first version of the GUI, which kind of got rewritten when we switched from Windows to Mac to Linux.
So I, primarily from the hardware side, I was working on the motors. So that included both the servo motor board, which I brought up initially with the staff motor board, and then I switched to working on our brush DC motor, which used 2 H-bridge motor controller. We're obviously controlling PWM signals, which allows Bogo to move around. And then after that, for software, I started working with Doug on Bluetooth, and I started bringing up a Python application using Bleak, which is a package for managing your Bluetooth devices, and then integrating that into a Tinker Python app GUI. So that's how we're controlling Bogo, is just through these Bluetooth connections.
It's awesome.
Oh. Now it might be done.
We broke him.